Slides are visible now.
Yes, sir.
And are they changing?
Yes.
Okay. Thank you for pointing out.
Uh,
So let's continue.
yes, now changing. Yes.
Okay. Thank you very much. So if we talk about the example of the IC, so one of the classical example or one of the most commonly used example is the processor and the amount of complexity of transistor on an IC is of the order of the 3.2 billion for the 2016 i7 processor, and right now it's surpassed 10 billion. So what is the main thing? There is a huge gap between the IC capacity and productivity of the humans. So as the time is passing, so this gap is becoming wider and wider. So I have a quick question from the audience. So we can see that, and that's a gap that is becoming higher and higher over the years. So this gap is a problem, or that is good or bad? Anyone in the audience?
Yeah, it's not the right thing because
It's being engineer having this kind of trend of the lowering of productivity as compared to the IC capabilities. Is it favorable for engineers or bad?
yeah, it's bad. I think.
No, it's not. Actually, this is a huge opportunity. So, what is the bread and butter of the engineers? That is, is there any problem? Engineers come and solve that. So this gap is actually the main thing, that is the opportunities. If somehow this gap is narrowed down, the opportunity windows that becomes narrow and narrow. And this huge gap is mainly the new jobs for the newcomers. So luckily, so this gap is keeping on increasing and increasing. So that's why there are huge openings around the globe for the IC design engineers. And this trend is true for last few decades. And if we look at the major sections of the IC design, so it can be categorically divided into the analog, digital, and by using these two, there are the mixed signal domain that is used the interface between analog to digital domain, and then the fourth that is a quite different, even the PDK, that is a memory segment. So the constraint for them that are the a little bit different from each other. And if we look at the IC design cycle, so first of all, when we're talking about the processor, so I showed earlier about the Core i7 processor, the transistor count is about 3.2 billion. So that's quite a huge and complicated system. So when someone want to design that IC, it's not readily to go and design the complete processor. First thing is to look at what are the requirements. So if we look at the just the processor of a simple mobile, that's not even the up to date or modern mobile. Even the mobiles in the early of 2010 and so on, so that have the different kind of sub blocks. So once some design engineer want to design that, the first thing is, first of all, design, divide and conquer. So we need to divide that complete processor or complete IC into its sub block, as we've done over here. So for dedicated purposes, we need to divide or segment each of the a complete IC or any working system into sub block, and then treat block by block. So that is first of all dividing, partitioning, and model the solution for that sub part, and then what are the tools required for that interface, and verify and validate and develop the flow to need to achieve that design. And if we look at in a very brief manner, what is the integrated designs, IC design cycle, that it start from the development of some schematic or some RTL, then we do it simulation and verify that the things that we expected from the design, we're getting those results. And then port that to the physical design that is known as the layout, that is physical design, and then we run some DRC and LVS check. So that makes sure that the physical design is the same as we are expecting in the simulations or the schematic design. And after that, then there are some very log digital synthesis that is designed for required for the testing, and then top level ICS compilation, that is the adding of the pad frame for the testing, and then finally the packaging. So again, this looks very simpler one, but believe me, that's not that much simple. So in each and every cycle, we have to go back to the previous one and iterate multiple times to achieve the desired results. So it seems that the IC design is extremely complicated. So the first question is, from where we can start to learn these skills. So if, in my opinion, the most important thing is to learn in very thorough detail the basics of the CMOS. This is the most key area that the newcomer should focus. So no matter the IC consists of 10 transistor or the millions, the main thing that needs to be very, very clear, that is designing at transistor level. And once the transistor level or CMOS basics are clear, then we can design the very complex VLSI and the verifications. So the basic building block is first of all designing of the characterization of the individual CMOS. And once we combine different CMOS together, what are their trends? What are their characteristics? So after understanding of basic CMOS, then on top of that, combining combination of a few, what's the implication? And by a little bit tweak in the gate, source, or drain of this MOSFET, what other trends are going to be changed? So whenever we're designing any of the complex logic, actually we're doing that one. So sometime we are having a premature IP core we're using, and on top of that we want to modify. And believe me, but just by changing little bit in the configuration of a single transistor, whole of the operation of the transistor or system can be changed. And what is the key to analyze that? That is understanding of the basic MOSFET. And after thorough understanding of the basics of the MOSFET, then CMOS based basic circuit design and analysis, and VLSI design and verification that involves the RTL coding, as Mr. Jafar was talking about, that the very hands-on experience on the RTL and VLSI coding, that is the must thing for this area. And then comprehensive IC design and verification tool training. So one important thing is the used to or being playing with the tools. So there are the tool sets. So the experience expertise is quite important and quite in demand in the market. So if someone is looking for where to start, so these are, I can say, that are this key pointer to look for. And again, I see global business and opportunities. So as Mr. Jafar was saying, that till the time of 2019, the global market was about 400 billion. And by 2022, this market has already surpassed beyond 600 billion and it's expected to increase beyond 1 trillion by 2027. And you can see that a major contribution of this market is, or the major chunk is held by the US, and that is the rest of the world is containing like 53% and 47% by the US. And is there anyone who can let me know what is the Pakistan foreign debt? So we are talking too much about the economic miseries of Pakistan. So what is the foreign debt of Pakistan? And for everyone, this is an interactive session. If at any time anyone want to interrupt, I am free to take the questions. So as per my knowledge, up till now, Pakistan foreign debt is about $127 billion. So which is a very huge and critical issue for the Pakistan right now. And then one of the Samsung Electronics is one of the leading company by the South Korea that is generating the electronics products. IC design and the fabrication is one of their sub business. But if we talk about their annual revenue, as per their report in 2022, their annual revenue is $2,234 billion. So this is the amount of business that this kind of company can grow. So we cannot think about that kind of business right now. But this is just some glimpse of the idea. So if these kind of industries are getting rooted in the countries like Pakistan, we can have a very huge or immense revenues that can be over there. This is the IC global market share. So one thing to look for here is that United States is 47% and South Korea is 19%. And we are talking too much about China, but one of the thing that to look over here is that the China global share is just 5%. And now they are have the doing the vigorous effort to increase their market share. And why? Because it's assumed that in the course of next 10 years, huge of the electronic or the technology dependency on the chiplets. So they are making a huge investment in this regard to get self-sufficient on this kind of technology. And again, so it can be seen that if the IC market can be divided into the logic, that is the some kind of processor, then the analog side, that can be the sensors and this kind of stuff, and the memory and discrete devices like the chips we are using for the designing using discrete component. So if we are talking about the Korea, the 90% share in global market, but they are dominating majorly on the memory area. So what's the takeaway from this one? So it's possible that instead of being expertise in all of these one, if we can get expertise even in a single area, then that can be a big or huge business opportunities. So in this regard, the we in the academia and the people in industry need to think carefully that what kind of the areas should we think about and should excel, so that even if not all of the areas, even in a single area, there are huge business opportunities. And if we look at the IC business ecosystem, that can be fabless. Fabless are the companies that are just designing and not doing any of the fabrication. For the fabrication, they take the services of any third party, and the examples we would see later on. And then the foundry that don't design their own chips, they just take the designs from the fabless company and just manufacture them. And then IDM, that is integrated design and manufacturing, they design their own chip and also fabricate. And then OSAT, that are the assembly companies. So after the manufacturing of the ICs, they just assemble and test them and ship to the customers. So if we look at the companies by their revenue models, so if we look at the top one are the Intel and the Samsung, and both of them are the IDM that design and also manufacture their chips. So their volume of this chip business is of this one. And then the TSMC is only the foundry, so that doesn't have their own design house, they just do the fabrication. And then SK Hynix, Micron. And if we look at the interesting thing, here are the Broadcom and Qualcomm. So these two are the totally fabless. What is meant by fabless? They're not making or manufacturing any of this stuff at their own. So they just design and then sublet to the foundry for the fabrication. So still they are making quite good business in billions of dollars. So what is the takeaway from this one? So business model can be IDM, foundry, or the fabless. So these three comes out to be major business model. And so first of all, let's talk about why not to start
Sir,
the IC. Yes.
sir, in this list of IC companies, why is China not included? Are there no
Actually,
companies
that is
in China?
in China, but these are the top 10 in term of the revenue. In the top 10 IC companies in term of revenue, there is no Chinese company. So this is the
So
list of the top 10
are they
companies ranked based upon their revenues.
are they currently investing in
Yes, so
uh,
that is the big opportunity
or-
that in the next slide we're going to talk about. So China is not in the top 10 in list of company in any of the IC design business. So now they have the huge focus on building their own capacity.
okay.
Okay. So if someone says that why not start with the foundry business? So the chips are built in huge factories that are called the fabs, and the contain cleaning. They have the clean room where all of this activity of the fabrication take place, and that are the bigger and more bigger as compared to the football fields. And the cost of such a fab is of the order of tens of billions. So that is the one thing that why I see design fabrication is very complicated, and across the globe there are very few fabs. And then if someone say that, then if someone want to think about the IC designing, so what is the requirement for that? For the IC designing, the requirements are a little bit relaxed as compared to the fabrication side. The most important ingredient required for designing side is the design tools. And on top of that, the most scared or most precious resource in the IC designing, that is the human resource. So we are talking about that. So that is the one of the key challenge that the global industry is facing right now, that is human resource that is trained on these CAD tools. And the two major professional IC design tool providers are the Cadence and Synopsys. And the cost of these one for the research bundles are of the order of $30,000, and but for the industrial license, the cost is around 1 million. But still, this 1 million cost still is very low as compared to the fabrication companies that cost at least a few $1 billion. So this is my personal opinion about the IC business and Pakistan prospect, that if we talk about the IC fabrication business, so that requires huge capital investment. And looking into the current situation of Pakistan, I cannot see that to be happening in the near future. And then becomes the second option, that is the IC design business. So if we look over there, the capital investment is relatively lower as compared to the fabrication side. So that seems to be a favorable option for the Pakistan. So if we see that if there in the world any successful IC design globe model exists, so one of the good model is the India that has right now more than 1,000 small business that has less than 50 engineers and IC design houses, and almost all of the global silicon giants are have their offices over there, and still India don't have any of fab in India right now. that is commercial fab. And similarly, we can see in on top of India, there are good example like the Morocco that has numerous small IC design company, and ST Micro that is one of the leading company have design house over there. And in the recent past, there has been a huge activity in the Malaysia and the Bangladesh. They are also having the huge revenues in terms of IC design business. So by following same, inshallah, in Pakistan we can have some kind of the good stream of revenue in coming future. And then comes the question that why the Pakistan special for now? And in my opinion, the biggest thing that is the recent global silicon crisis and USA China silicon autonomy focus is the biggest game changer that's gonna be play a huge factor in the coming years. And as we were saying earlier on, China has only the 5% market share, but recently the USA have imposed quite much sanctions on the China to block the access to the new technology. So China has to move to and look for the modern technology and focus more on to the IC design business. So they are investing a lot, and once such a huge investments are done, it comes with the not only the opportunities for the China and also for the nations that are around that. And secondly, the most of the developed countries right now are facing the issue about the lesser birth rate that implicates the lesser count of the new generations. So, but contrary to that, Pakistan has the bulk of EE and CS graduates human resource. So this is one of the thing that's gonna be a huge and critical thing that's gonna be help out us inshallah in the coming year, that we have the huge number of EE graduates. So if we somehow can train them into the field of the IC design, that can be a great asset for that can be help us somewhere like the fetching the business from the overseas, or also that can create huge opportunities for the graduates in the overseas market. And one of the important thing is that over the past 2 or 3 years, there has been sustained academic and startup venture for past few years. So one thing is that, so over, if I recall, I came back to Pakistan in 2020, and at that time I cannot hear about more than one name in the IC design business. And but for the 3 or 4 years up till now, there are five or seven companies that are sustained over the few years. So that is a good thing that companies are becoming developing, and after developing, second thing is their sustenance. As Mr. Jafar said, that they have grown over the 2 year from 6 to 60. That is 10x growth. So this kind of growth shows a remarkable opportunities for the newcomers. So there was there was one question by some of the audience that we cannot see China over there. So the one of the main cause of this China is that there is the huge sanction on this kind of technology that is imposed, that is between China and USA. So these are the top 5 or 6 blocked Chinese semiconductor transaction that Chinese companies try to acquire, but the some kind of the issues, legal issues that abandoned or block those kind of transactions. And this is reported by the US Industry Global Competition and Federal Policy 2019. So that is a well documented report, that is a public report. So we can see that China is have this putting a serious effort to have the access to these kind of modern technologies. And after being seen that they are not able to get those kind of technology directly from the USA, now they have started building their own capabilities. And it's they are expecting that by the 2030 they would have made quite sufficient progress in this regard. So the one question comes over here is that when we are talking about so much complicated market scenario and so much competitive industry, is there any case for the Pakistan to survive in this kind of scenario? So in this regard, I would just like to introduce my lab, that is the IC Design Lab at the Fast Newsys. So that was established in 2020. So I would just like to give a brief overview about establishment of this lab. So the NICOP wanted to establish the IC Design Center in the Pakistan. And the first challenge they came encounter, that was the lack of human resource. And in that time, they collaborate. They asked the proposal from the multiple universities, and including the FAST, we put the first proposal that we would train the IC designer with the one notch capability, that they would be able to design the ICs that are ready for the fabrication, which is known as a tape out. So in this regard, 2020, the 2020 IC Design Lab founded in FAST, and right now it is led by Professor Dr. Rashid Ramzan, who is a PhD from the Linköping University, Sweden, and I am all Dr. Hassan Saif is also part of the same lab, and we also have two lab engineers, Ali Sabir and Usama Liaquat. And over the past 3 years, 40 graduate has been graduated from this lab, and there are 60 current graduates right now enrolled in this program. And what is the key feature, that we have the cadence license tools and the access to the 28, 65, 130, and 180 nanometers PDKs. And more, the important part of this program is more than 200 hours training on CAD tools, which is very, very essential requirement, and that is the key skill that is looking the industry is looking for. And in this one we covered the strong the all of the basic IC design courses that covering from the analog, digital, mixed signal to the verification, those would be covered. So by taking this course, we can say that the basic fundamental ground is clear. And someone says that I want to expertise into the digital design. So it's not right approach to just take the digital design stream. So first of all, basic or fundamental in all domains are getting cleared, and then later during the thesis or stage, those can excel in some specific area. And one important thing is comprehensive tape out experience. And what is tape out? That is the design that is ready for the fabrication. So all of the graduating batches have this kind of tape out experience. They themselves think about some project and design its corresponding IC that is ready for fabrication. And over the past few years, we have collaborated with the various national and international industry. We will talk about that later. So after the start of this program, we were getting the demands from the industry that, as Mr. Jafar is saying, that in the industry there is huge demand of the IC design engineers. And if we span the MS program in a traditional 2 year fashion, then the time to market is quite huge. So we have tailored the program in such a manner that the after 10-month coursework, all of the major courses are done, and after for the rest of the thesis they can move to the industry and join the industry, and from there they can take the industrial project or can have the thesis in the industry. So in this program, the important thing is that after 10 months students are able to join and move to the industry. And this is the and in this summer the third batch has completed its 2 semesters, and out of that third batch only more than 85% are on job, and only 15% are there also waiting for some interviews. So up till this time the trend is that after 10 months the people get job in the industry, and from there they continue their thesis. And if we look at the achievements, so being academia, our achievements is most logically are the publication and the taper project. And the first batch that graduated in 2021, they did 8 projects on TSMC 65 nanometer technology. That were 2 ICs, Kamal 1 and Kamal 2, and they were named after Dr. Vais Kamal, who is the founder of the fiber optic network in the Pakistan. And so these were 8 projects. And then also we participated into the IEEE SSCS PICO event. So that is the annual project call that invites the proposal from around the world. And from those proposals, they select the limited one for the fabrication, and they provide the fabrication funding for that one. So in 2021, we submitted overall 18 projects were selected globally. And out of those 18, 3 were from the FAST group, and these are the die photos of the Kamal one. So if you look at this one, this is 1 mm by 1 mm. So this is, you can see that on the fingertip. So these are Kamal 1 and Kamal 2. So that is just, so this is the size of the ICs we are talking about. So if we look at that, so if we want to see this kind of picture, that is the amplified from the microscope. So that kind of complexity we're talking about when talking about the ICs. So these are the 4 projects on the Kamal one. That was the ALU. That is ALU. What is the ALU? The processor is combination of ALU's blocks. So ALU can be scaled up to generate any of the processor. Then is the CLBs. So that is the building block of the FPGAs. FPGAs are the configurable logic blocks, are the backbone of design of, and CLBs are scaled to design the FPGAs. And low noise amplifier, that is the key block for the interfacing for the analog front end. And true random number generator, that is some kind of the encryption algorithm used for the security of the chips. And similarly, this is the die photo shot of Kamal 2. And Kamal 2 also consists of 4 projects. That is, one is the millimeter wave phase shifter that is used for the 5G system, and capacitorless triboelectric energy harvester that is used for the nano energy harvesting, and AC logic family. That is one of the idea that is, instead of traditional DC logic manipulation, we can transform that to the AC domain. And then multi MIMO channel estimation sigma delta ADC, that is also have application for the 5G systems. And then 3 project that was accepted in 2021 on the Pico, that was a sub 6 gigahertz bidirectional amplifier, so that can have the amplification in the both directions, and backscattering integration wireless power transfer. So wireless power transfer is one of the hot topic in the today's time, to provide the charging capability without the wires, and 64 with multiplying edge unit that can have the application toward the ALUs and the processors. And we continue the same trend in 2022. Worldwide, 22 projects were selected, and out of those 22 projects in PICO, 8 were from the FAST group, and the rest of the project 14 were from the top-notch university like the MIT, UT Austin, North Carolina University. So we can say that by sitting here in the Pakistan, we're competing with these kind of top-notch universities in these kind of competitions. And not only competing, wherever we are participating, we're getting a good chunk of the share over there. And these are the die photo shot of these 6 projects of the Pico 22. And the trend continued. The third batch that was enrolled in the last year, and now they have applied in the March, and out this year, overall 13 projects were selected, and out of those 13, 6 are from the Pakistan. So this shows that we have at least have some kind of good presence in these kind of international competitions. And by looking, so this kind of presence have earned us some good reputation globally. And GSMA, which is the Silicon Valley company, they had the plan to start the IC design center in the Oman. And the same, they were facing the challenge that the presence of the trained human resource. Just like Pakistan, in the Oman, there was no trained human resource in field of IC design. So before starting the design house, they planned to start the IC design training program. And in this regard, they collaborated with our lab, and over the past years, we have the goal to train 100 Omani engineers for establishment of first IC design center in Oman. And by the grace of Almighty Allah, so we have completed that training just last month in the July, and those 100 engineers are now trained, and they are now establishing the first IC design company in the Oman. So these are the, and that training was also accompanied by the complete silicon tape out experience. So which is this are the two chips that are generated in, and 9 projects over them in Oman. So these are the, and again, for the academic point of view, we look majorly on the publications. So we have 7 impact factor journals and conference papers, and a few are in the pipeline. And these are the list of few funding. So I think due to lack of time, we should just roll over from this point. And the good news for all of the graduates is that right now in Pakistan, there are many places where you can get the dedicated graduate program in IC design or have the dedicated courses. So these are